problem, free response, calculator portion, problem number 1. So we have here this table. We have to answer this question. So we were graphing the function. We have here h, and then a of h will be the area. H is for height of a certain tank with a height of 10. And so we know the function is decreasing. And so for the first thing here, we could also say that a is continuous and decreases as the h values increase. So for the first part, we are required to find a Riemann sum with the 3 sub-intervals indicated by the data. So we don't need to divide them into equal intervals. We're just going to take those points like that. So like this will be our first, second. In fact, this will be our first interval, second interval, and third interval. All right? Now, since they're requiring us to use the left Riemann sum, it's going to be like the left. So our first interval is from 0 to 2. So the left corner is going to be at 0, and that's when it touches the function, and then you trace your rectangle. Then the next one will go from 2 to 5. So the function, the rectangle on the left is touching the function, and then the last one will be here. And then it touches here. So we have all our 3 intervals there. That's important to trace in case you forget if there's going to be an over or an underestimate, because that's the question for part B. All right? So then we're going to expand that Riemann sum. And what we're going to do to answer that part A is we're going to say the integral. Now, another thing, if we are measuring the height and then the area, what are we going to get, guys? The volume, yes. And so that's how we're going to find the volume, by calculating the integral from 0 to 10 of the function a of h, and we're integrating with respect to h. Now, our intervals for the first one, the width is going to be 2 minus 0, the width of the rectangle, and then the height is actually going to be the function value at 0. Remember, the left corner of the rectangle. Right here, that one. Okay? And so those values are going to come from here. Then for our next interval, we're going to need a of 2, so we're going to need that value. All right? Then for the next interval, we're going to need a of 5, and that will be the function value at 5, because that was our last left corner touching the ground. All right? So I'm going to go back here where we're writing them. And we have that. Second interval, our width is going to be 5 minus 2, the x values, and then times a of 2 plus the next interval is from 10 minus 5 to get the width of the rectangle times the height of the rectangle, which is given by the function value at 5. Okay, so that will equal to 2 times 50.3. We get that from here. Okay. First rectangle. The next rectangle is 3 times a sub 2, a of 2, which is 14.4. Remember, these are coming from the table, right? The table is actually your friend. And then the next one, we have 10 minus 5, so that will be 5. And then what is the value for a of 5? 6.5. Very good. Now, once you have that substitution, you can put it in the calculator, because this is a calculator-related question. And then 176.3 cubic feet. Or, of course, you could say cubic feet like that. All right? But it's very important to keep your units. I'll tell you how the points are going to be distributed in a minute. All right, now let's go to part B. Part B says, does the approximation in part A overestimate or underestimate the volume of the tank? Explain your reasoning. And, well, first of all, this part A is worth 2 points.
How many points do you get in total?
In total, this question was 7. 7. This part was 2 points. And 1 point is for having the correct units in parts A, C, and D. They do not mess around.
So we always threaten you.
Yes. Yes.
Even in the equation itself, or just when your answer is fine?
At the answer, yes. Yes. Okay, and then part B, does your approximation blah, blah, blah. You can see clearly that it's an over, right?
Yeah.
But you can't just answer with that because it says explain your reasoning. So if you don't explain, you don't get the points, okay? And that's only 1 point. So it's very easy to lose. So you are going to say that it is an overestimate because the left Riemann sum was used and that function in function A was decreasing. That's enough. That's a great explanation. Even if you don't know why. Okay, just say that. But don't get lazy and write it down. So it is an overestimate
Can you say it? Or do we have to like say what?
you could say, if you want to get more technical, you could say the approximation.
Are we allowed to say it though or no?
I think either way it will be fine.
I mean, it's not.
Actually, the it is from the answer. Yes.
Oh, yeah.
Yes.
Alright.
Overestimate because they left Riemann sum was used. Yeah, so I have the answer key for the free response. I don't have for the multiple choice. It's decreasing. All right. And then let's see, for part C, the area in square feet of the horizontal cross section at height h feet is modeled by the function f given by f of h, blah, 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 blah. And you're like, oh my God, I don't know what to do because he's never taught us that, which is true. But it's okay. We can get through this. Okay, so we're going to do the following. Oh, and actually, I have a great picture of what a cross-sectional area is. With a project I helped my son with of the layers of the earth. Yeah, but I'll talk about that later. So anyways, we're going to do the following, guys. We're going to do the integral from 0 to 10 of f of h. Now, the equation for f of h is provided to us, so we're just going to take advantage of that. So it is 50.3, and of course, because we're going to answer it with the calculator, we still need to do a substitution, okay? And this is a 0.2 h for the exponent, and then plus h to the first power. So we do that, and then dh, and then we need to get an approximation. And then let me tell you how the points are here. So we said this is 1 point, right? For part C, you're going to get 2 points. One of them is just for setting up the integral. 1 point for that. And the other point is going to be for your response. And come on, if you have this one, you have to get this one, right? Because you know how to enter these things on the calculator. So, yes. Question?
Yeah. Can you just put f of h, dh, or do they actually want to see that you plugged in f of h?
I would just substitute it just to make sure.
Okay.
Yes, just, I mean, if you're running short on time, that would be like one of those life or death decisions. Okay, so the answer, guys, practice with your calculator, is gonna be this. What's gonna happen if I don't put the units there?
You get no points.
I'm not gonna get the first point from the top. Cubic feet, right?
Wait, hold on.
All right, now D.
Please.
What's the question, Kayla?
It's water is pumped into the tank when the height of the water is
Oh.
5 feet.
Go ahead, go ahead.
Okay. The water is 5 feet. The height is increasing at the rate of 0.26 foot per minute. Using the model from part C, find the rate at which the volume of water is changing with respect to time with the height of the water is 5 feet to keep units of measure.
Okay. All right. So what we're gonna do here is we're gonna find the volume, which we already know it was gonna be. What was that other function over there? It was the area, right? And then times h, times the height. So now what we're gonna do is use the integral of f of h. Now, why from f of h? Because they're giving us if you look at part C, it says the area in square feet of the horizontal cross section is modeled as that. So then that is already the area. So then if we integrate that, we're going to go to volume. All right? And so we take here from 0 to h, and then f of x dx. All right, now what does this mean? It means that the way the volume is changing with respect to time is going to be equal to the two products, to the product of the difference in the volume with respect to the height times the difference on the height with respect to the time. So once we have this, we could see that those two cancel, and that's how you get your dv over dt. Now, what does this mean in terms of our functions, right? So,
Can you go over that part again?
let me finish it and then we'll retrace.
Okay.
So, if we do this at h equals 5, then it's going to take us to this part right here is going to be the function at h, and then this part here is still dh over dt, and we want that when h is equal to 5. So then let me write the sentence, okay, and then we'll go back to the whole thing. So when when the height is equal to 5, the volume of water is, I'm sorry, right here, there's still like an answer for it. So then we will, to find the final answer, we will find f of 5, which is given by the table, right? And then we are going to multiply it by this quantity here. And so that one becomes 0.26. So then the answer for this one will be 1.694419. Okay, so when h is 5, the volume of the water is changing at a rate of 1.694 cubic feet. Okay, so let's go back to the question. So water is pumped into the tank. When the height of the water is 5 feet, the height is increasing at a rate of 0.26 foot per minute. Okay, so that's where that 0.26 comes. So the question says, I'm gonna read it again. When the height of the water is 5 feet, so right here for h equals 5, at 5, remember, it's kind of like when you evaluate integrals. So you substitute the 5 here, and then you also, okay, so let me go back on this one, and then we'll go back over it. Is the notation the one confusing you? Okay, so now the 0.26 foot per minute is actually on the question.
Yeah, that's the
Okay.
one which
Yes. And then it says using the model from part C. So we take the model from part C. This, right? Find the rate at which the volume of water is changing with respect to time. So the rate at which the volume is changing with respect to time. So that's why we need dV over dt. All right? Now, how are we going to find dV over dt, right, based on what we know? The only things that we know is this one because it's given by the question. It says 0.26. And you have to, like, listen to the units. Foot per minute. You see, at a rate of 0.26 foot per minute. So, height changes at the same time as time changes. Now, because we want to get to this one here, and let's say we know this, right? So we have to think about a quantity that perhaps might have dH on the bottom, so that we can cancel this dH with this dH, and so that we get to the actual rate that we're looking for. Okay? So then what can we use? So then we could use, from the previous problem, we actually found the volume, right? This was the same thing, to find the volume.
Yes.
Right? So then, we take that same function, and, I'm getting lost. Okay, so with that one, what we did was to find the volume how the volume was changing with respect to the height.
So then when you derive that formula, you basically cancel out the integral. And so then you're just left with f of h. I mean,
Yes, we could see it that way as well.
So happy.
But look, this is the volume based on height.
Yes.
So if you were to, like, in reverse, you will be, if you were to derive that, you're calculating how fast is the volume changing with respect to the height. That's why, like, I really like this notation. I think this is my favorite notation. All right. Now, explanation. When h, the volume of water, is changing at a rate of, when h equals 5, the volume of water is changing at a rate of 1.694 cubic feet. Okay, so we don't have time to do the next one, but the good news is the next one is not so hard, okay? And we're gonna do it in its calculator.
Isn't it per minute? Because why would you just lost the point?
Can I have the answer?
And you had to work, you had the answer in it.
Oh, where's my answer key? Okay. I'll tell you exactly what.
Wait, I remember how to do this though. You don't want to do it.
Per minute. Yes, per minute, guys. Okay, so I know you have a very stressful week, but please try to do at least 10 questions of your multiple choice.
After the 8 weeks, how much is dedicated to the
When is Stacy said tomorrow, right?
Yeah.
Oh, thank God.
I'll have one week.
And then
One week
we
dedicated to
could actually set times to practice, not like during CP
Oh, okay.
or who
During
has
CP would be good.
7? I mean 6.
6,
So yeah, I know I could take you guys, and then if you guys have like, does anyone have PE?
Yeah, I do.
I could get you guys from Mr. Leva who told me this one. We'll figure it out, okay? But Wednesday, please come to school.